What you eat isn't the whole story. It's what your gut microbes do with it. Your mood, your immune defenses, how well you absorb nutrients, even how tired you feel at the end of the day. A lot of that traffic is controlled by a tiny, invisible ecosystem living inside your intestines. And the shocking part? Some of the most common items in our kitchens quietly nudge that ecosystem toward imbalance. Today I'll walk you through 10 everyday foods and ingredients that can harm the gut microbiome, how they do it, why it matters, and realistic steps you can take to protect your inner community. Think of your gut as a living city. Microbes are its citizens. The mucus layer that coats your intestine is the city wall and protective paint, and your immune system is the local patrol. When that wall gets thin or the balance of citizens shifts, trouble can spread beyond the gut, into inflammation, altered metabolism, and even mood changes. Before we start the list, a quick primer so the mechanics make sense. The gut primer. What the microbiome actually does. Your gut microbiome isn't just about digestion. It trains your immune system, produces vitamins, helps harvest energy from food, and communicates back to your brain through the enteric nervous system, the so-called second brain. Research often cited suggests that a large share of the body's serotonin is produced in the gut, and many sources estimate a substantial portion of our immune tissue is associated with the gut-associated lymphoid tissue, GALT. Those are commonly cited estimates meant to show that this ecosystem has outsized influence on whole body health. Key structures and terms. Mucus, mucin. A protective gel that lines your gut wall. Think of it as a paint that keeps microbes at a safe distance from the epithelial cells. Enterocytes, the intestinal lining cells that absorb nutrients. LPS, lipopolysaccharide, a component of some bacterial cell walls. When it crosses from the gut into the bloodstream, it can trigger low-level inflammation, often called endotoxemia. Dysbiosis, an imbalanced microbial community. Too many of some members, too few of others. Firmicutes, Schacht, Bacteroidetes ratio. Shorthand researchers sometimes use to describe broad compositional shifts linked to obesity and metabolic changes. It's a simplification, but useful as a concept. Damage can occur in a few repeatable ways. Additives or certain fats can thin the mucus layer. High-sugar diets feed opportunistic microbes. Oxidized or damaged fats irritate cells. And some food processing creates compounds that stress the microbiome and gut lining. Over time, these shifts can be subtle. The microbiome changes quietly, but those quiet changes add up. If you want more deep dives that unpack how your body actually works and what to do about it, hit subscribe and stay with me. I'll share practical swaps and a step-by-step plan at the end. Now let's count down the 10 common foods and ingredients that can silently harm your gut microbiome. 10. Processed meats. What this includes: hot dogs, bacon, deli meats, heavily cured sausages, and many packaged meat snacks. Why it's common, convenient, long shelf life, and culturally popular. Processed meats often contain preservatives, nitrates, nitrites, and flavor-enhancing additives. How they can harm the microbiome. When meats are cured or cooked at high temperatures, nitrates and nitrites can form nitrosamines, compounds linked to cellular stress. High-heat cooking and charring also produce heterocyclic amines and polycyclic aromatic hydrocarbons, which can be irritants. These compounds don't just affect human cells, they alter the microbial environment in the gut, shifting which species can thrive. In addition, processed meats are often low in fiber and paired with high salt content, which can favor salt-tolerant microbes and reduce beneficial fiber-feeding bacteria. Over time, these changes can lean the ecosystem toward inflammation-prone communities. Practical alternatives and mitigations. Reduce frequency and portion size. When you eat meat, choose minimally processed cuts and cooking methods that avoid charring. Gentle roasting, braising, or stewing. Pair meats with fiber-rich sides. Vegetables, beans, whole grains, so your microbes get prebiotic nourishment. If you like cured flavors, try small amounts of traditional-style preparations or fermented plant-based alternatives that include live cultures. Number 9. Low-fat pasteurized dairy and certain commercial milks. What this includes: many low-fat milk products, some heavily processed yogurts, and supermarket milk labeled as low-fat or ultra-pasteurized. Why it's common. Low-fat is marketed as healthier, and shelf-stable milks travel well in the supply chain. How they can harm the microbiome. Pasteurization is a critical public health technology that kills pathogens, but it also reduces some naturally occurring bacteria and enzymes. Low-fat processing can strip away components that help with digestion and mucosal signaling. Some discussion in the scientific and consumer world concerns differing milk proteins, A1 versus A2 beta-casein, and a few people report intolerance to modern, highly processed dairy. Those claims are debated and not universal. What's less controversial is that the removal of live cultures and certain fats changes how dairy interacts with your microbiome compared to traditionally fermented or minimally processed versions. Practical alternatives and mitigations. Choose fermented dairy like live culture yogurts, kefir, and certain cheeses that contain beneficial microbes. But read labels and prefer products with live and active cultures without added sugars. If you tolerate whole dairy, full-fat versions can provide fat-soluble nutrients and slower digestion. If not, plant-based unsweetened alternatives combined with fiber sources can fit well. If you're exploring milk protein concerns, work with a clinician or registered dietitian before making drastic changes. Avoid unregulated or illegal sources such as untested raw milk. 8. Healthy branded processed foods. What this includes: foods marketed as healthful but heavily processed, sugary granola bars, flavored yogurts, protein bars with long ingredient lists, many plant-based convenience products. Why it's common. Branding convinces us these items are healthy, they're convenient, and they appeal to busy lifestyles. How they can harm the microbiome. Packaged healthy snacks often hide sugar, refined starches, industrial seed oils, more on those later, emulsifiers, and preservatives. Hidden sugars and refined carbs feed fast-growing opportunistic microbes and yeast, like Candida, which can shift the community away from fiber-loving beneficial species. Emulsifiers and stabilizers in these foods can also impact the mucus layer and gut barrier. The result? A microbiome increasingly dominated by sugar-loving organisms and less able to support immune balance. Practical alternatives and mitigations. Read the label. Favor whole food snacks, plain nuts, fruit with nut butter, plain Greek yogurt with fresh fruit and seeds, homemade granola where you control sweeteners and oils. If you're using plant-based or convenience products, pick those with short ingredient lists and minimal additives. 7. Emulsifiers and certain food additives. What this includes: polysorbate 80, carboxymethylcellulose, carrageenan, xanthan gum, some stabilizers and thickening agents found across packaged foods. Why it's common: they improve texture, extend shelf life, and make low-fat or shelf-stable products palatable. How they can harm the microbiome. Animal and in vitro studies suggest that certain emulsifiers can thin the mucus layer and change microbial behavior, enabling microbes to get closer to epithelial cells. Some additives may also alter microbial metabolism and promote inflammatory signaling in susceptible individuals. The evidence in humans is still developing, but mounting lab data raises concern that habitual exposure could nudge the gut toward dysbiosis. Practical alternatives and mitigations. Minimize heavily processed foods that list these additives among the first ingredients. Cook from whole foods when possible. Use recipes with natural thickeners, pureed vegetables, chia, ground seeds, instead of relying on industrial emulsifiers. For packaged food purchases, prefer items with simple, recognizable ingredients. 6. Alcohol, especially binge or chronic use. What this includes: beer, wine, spirits. The issue isn't a single drink, but frequency, pattern, and amount. Why it's common. Social drinking is widespread and culturally ingrained. How it can harm the microbiome. Alcohol can irritate and damage enterocytes, the absorptive cells, and reduce mucin production, thinning that protective mucus paint. It can increase intestinal permeability in some people, allowing bacterial components like LPS to translocate into circulation and trigger inflammation. Alcohol metabolism creates acetaldehyde and other metabolites that are toxic to cells and can alter microbial composition, favoring species that tolerate ethanol and disadvantaging others. The pattern matters. Chronic or binge drinking exerts a much stronger negative influence than occasional, moderate consumption. Practical alternatives and mitigations. Moderate intake and avoid binge patterns. Drink water between alcoholic beverages, choose lower alcohol options, and prioritize days off from drinking. If you're concerned about gut symptoms or heavy use, seek guidance from a healthcare professional. Fermented non-alcoholic options, kombucha with low sugar, kefir water, shrubs, can provide some sensory satisfaction and microbial-related benefits without ethanol, but check sugar content. 5. Modern wheat and gluten-containing refined products. What this includes: Many refined breads, pastries, and products made with highly processed modern wheat varieties. Why it's common. Wheat is cheap, versatile, and ubiquitous in Western diets. How it can harm the microbiome. Wheat contains gluten proteins. Parts of those proteins, like gliadin, can interact with intestinal signaling molecules and, in susceptible individuals, are linked to increased intestinal permeability. Research suggests that modern agricultural breeding has increased gluten concentration in many wheat strains, which could change how the gut reacts for some people. For most people, gluten-containing whole grains can be part of a healthy diet. The concern is refined wheat products and highly processed baked goods that lack fiber and are high in added sugars. These feed fast-growing microbes and reduce diversity. Practical alternatives and mitigations. Prefer whole grains, whole wheat, barley, oats, spelt, that contain intact fiber and feed beneficial microbes. If you suspect gluten sensitivity or celiac disease, consult a clinician for proper testing rather than self-diagnosing. Eliminating gluten when it's not indicated can complicate assessment. For many people, cutting back on refined baked goods and increasing diverse whole grains will benefit the microbiome. 4. Artificial sweeteners. What this includes: aspartame, sucralose, saccharin, acesulfame potassium, and other non-nutritive sweeteners used in diet or zero products. Why it's common. Marketed as calorie-free sweet solutions for weight control and blood sugar management. How they can harm the microbiome. Several studies, including human and animal work, suggest that artificial sweeteners can alter microbial composition and metabolic signaling. In some experiments, changes in gut microbes after exposure to sweeteners were associated with altered glucose tolerance and metabolic responses. The mechanisms are still under investigation, but the take-home is that these compounds are not biologically inert. They interact with microbes and host systems. Individual responses vary, and more research is needed to clarify long-term effects. Practical alternatives and mitigations. Reduce reliance on artificial sweeteners. If you want sweetness, use whole food sources, fruit, or modest amounts of natural sweeteners while prioritizing whole foods and fiber. When using sweeteners for medical reasons, for example diabetes, discuss options with your healthcare provider. Do not make changes without professional guidance. Chapter 3. Industrial seed oils, highly refined vegetable oils. What this includes: canola, soybean, corn, sunflower, safflower oils that are industrially processed and used for most mass-produced snack foods and many restaurant cooking operations. Why it's common. Cheap, high smoke point, suitable for frying, and used widely in food manufacturing. How they can harm the microbiome. These oils are high in omega-6 polyunsaturated fatty acids. While omega-6 fats are not inherently bad, they are essential. Excessive omega-6 intake relative to omega-3s can promote pro-inflammatory signaling in the body. Industrial processing can oxidize these oils, creating lipid peroxides and other oxidation products that irritate the gut lining and change microbial communities. Oxidized lipids may impair bile signaling and alter which microbes can thrive. Over time, a diet heavy in oxidized or overly abundant seed oils can be corrosive to the gut environment. Practical alternatives and mitigations. Use stable, minimally processed fats for cooking, extra virgin olive oil for low to medium heat, butter or ghee for higher temperatures when appropriate, and avocado oil for moderate high heat cooking. Reduce consumption of packaged snacks and fast foods cooked in industrial seed oils. Prioritize foods rich in omega-3s, fatty fish, flax, chia, to balance the fatty acid profile. 2. Fried foods and foods cooked at high heat. What this includes: deep-fried snacks, fast food fries, battered fried items, and repeatedly reused frying oils. Why it's common. Texture and flavor appeal, convenience, affordability in many settings. How they can harm the microbiome. Frying and repeat heating cause fats to oxidize and generate advanced glycation, end products, AGs, and other damaging compounds. These oxidation products can irritate the gut lining, impair bile acid signaling, and shift microbial populations toward species that tolerate oxidative stress. The process also creates damaged lipids that the body must detoxify, increasing inflammatory signaling and potentially favoring dysbiosis. Practical alternatives and mitigations. Limit fried foods. When you do indulge, choose items from places that use fresh oil and moderate frying temperatures. At home, air frying or baking can produce similar textures with less oxidation. Use stable oils and avoid prolonged high-temperature reuse. Balance indulgence with fiber-rich, plant-forward meals that feed beneficial microbes. Muffitter 1. Sugar and refined carbohydrates. What this includes: table sugar, high fructose corn syrup, white bread, pastries, sugary beverages, many breakfast cereals. Why it's common: sugar is cheap, highly palatable, and used across processed foods. How it can harm the microbiome. Sugar and refined carbs are the fastest fuel for opportunistic microbes and yeast. Diets high in refined carbohydrates favor fast-growing bacteria and Candida species, reducing microbial diversity and starving fiber-dependent beneficial taxa. This encourages fermentation patterns that can produce gas, bloating, and metabolic signals linked to insulin resistance. High sugar intake also promotes low-grade systemic inflammation over time and can contribute to adiposity, changes that feed back onto the microbiome in a vicious cycle. Practical alternatives and mitigations: reduce sugary drinks and packaged sweets. Replace refined carbs with whole food carbohydrate sources, legumes, root vegetables, whole grains, and fruits. Add fiber at every meal to provide prebiotic substrates for beneficial microbes. If you crave sweets, satisfy the urge with fruit, dark chocolate with minimal added sugar, or yogurt with fresh berries. Interlude: why early life matters and how generational trends show up. The gut ecosystem begins forming at birth and during infancy. Babies get their first major microbial exposures from the mother, via the birth canal, in vaginal deliveries, via breast milk, and through close environmental contact. These early exposures help train the immune system and shape tolerance to foods and microbes. Many sources suggest that breastfeeding, exposure to diverse natural environments, and avoidance of unnecessary antibiotics during early life support healthier microbial colonization, though each family's context matters. Modern trends have changed the starting point for many children. Higher rates of cesarean births, increased antibiotic use, more sterile home environments, and diets dominated by processed foods can reduce microbial diversity passed across generations. The transcript that inspired this piece raised controversial ideas about raw milk and vaccine impacts on microbiomes. These are debated topics. For raw milk, there are claims about tolerability in certain groups, but raw milk also carries infectious risks and legal restrictions in some places. It's not a universal recommendation. Regarding vaccines, mainstream medical guidance supports them for preventing infectious disease. Any discussion of their effects on the microbiome should be balanced and anchored in robust evidence. The broader, less controversial point remains: maternal health, early feeding practices, and early antibiotic exposure can have long-lasting effects on a child's microbiome trajectory. Prevention starts early. If you're planning a family or supporting young children, encourage breastfeeding when possible, promote natural varied exposures, play outdoors, pets if appropriate, avoid unnecessary antibiotics, and prioritize nutrient-dense, fiber-rich foods. For parents, remember that small changes in the household diet shift the microbial environment for everyone. Deep dive: how gut damage translates into whole-body effects. We've talked about mechanisms locally: thinning mucus, shifts toward sugar-loving microbes, oxidized fats irritating the lining. But how do these local changes ripple outward? Imagine your gut mucus as a thick paint that keeps microbes in their lane. When that paint thins, microbes can interact more closely with epithelial cells and immune sensors. Those interactions can trigger immune cells to release cytokines, signaling molecules that travel throughout the body. If microbial components like LPS cross into the bloodstream because the barrier is compromised, they can cause a low-level systemic inflammatory response. This chronic low-grade inflammation is a common thread linking gut dysfunction to metabolic problems like insulin resistance and weight gain, to mood alterations through immune-to-brain signaling, and to certain autoimmune or inflammatory conditions in susceptible people. Another mechanism is resource availability. Diets low in diverse fiber starve the bacteria that produce short-chain fatty acids, SCFAs, like butyrate, which are critical for nourishing colonocytes and maintaining barrier function. When SCFA production drops, the gut lining loses a key fuel source, further weakening the barrier and perpetuating a cycle of dysbiosis and inflammation. Finally, microbial metabolites can modulate neurotransmitters and vagal signaling, pathways connecting the gut to the brain. That's one reason why dietary patterns and microbial changes are increasingly linked to mood and cognition research. It's not simple causal proof that a single food causes depression or anxiety, but accumulating evidence shows that gut-related inflammation and altered microbial metabolites can influence brain function. Practical prioritized action plan. What to do next? You don't need to overhaul your life overnight. Small Sustainable Steps compound. Here's a prioritized checklist to get your microbiome back on a healthier path. 1. Increase fiber and diversity. Aim to include multiple types of vegetables, fruits, legumes, nuts, seeds, and whole grains across the week. Different fibers feed different microbes. Diversity is the name of the game. 2. Add fermented foods. Unsweetened yogurt with live cultures, kefir, sauerkraut, kimchi, and miso can introduce beneficial microbes and increase diversity. Start slowly if you're sensitive to fermentation. 3. Cut down on the obvious offenders. Reduce intake of sugary beverages, refined baked goods, and frequent fried or processed fare. Prioritize whole food snacks and meals. 4. Read labels. Watch for emulsifiers, long ingredient lists, added sugars, and industrial seed oils. Favor products with short, recognizable ingredient lists. 5. Choose better fats. Swap heavily processed seed oils for extra virgin olive oil, avocado oil, butter, or ghee where appropriate, and include omega-3 sources like fatty fish or plant-based seeds. 6. Moderate alcohol. Keep drinking occasional and moderate. Avoid binge patterns. Replace some drinking occasions with non-alcoholic fermented beverages or flavored sparkling water. 7. Cook wisely. Use gentle cooking methods, avoid charring, and limit deep-fried restaurant meals. When frying at home, use fresh, stable oils and moderate temperatures. 8. Focus on early life supports if relevant. For parents or those planning families, support maternal nutrition, breastfeeding if possible, and avoid unnecessary antibiotics while working closely with providers. 9. Consider professional guidance for persistent issues. If you have chronic gut symptoms, complex conditions, or consider major dietary shifts, work with a clinician or registered dietitian who understands functional nutrition and microbiome science. 10. Be patient and consistent. The microbiome responds to sustained change. Meaningful shifts take weeks to months, and setbacks are normal. Recap the 10 items, quickly. 10. Processed meats, nitrates, high-heat compounds, low-fiber pairing. 9. Low-fat pasteurized, overprocessed dairy, loss of live cultures and structural changes. Debated specifics like A1 and A2 require nuance. 8. Healthy branded processed foods, hidden sugars, emulsifiers, seed oils. 7. Emulsifiers and additives, mucus thinning and microbial behavior changes. 6. Alcohol, mucin reduction, enterocyte damage, LPS translocation risk. 5. Modern wheat refined gluten products, refined carbs and, for susceptible people, gluten-related permeability issues. 4. Artificial sweeteners, microbiome shifts, and altered glucose signaling in some studies. 3. Industrial seed oils, oxidative products, imbalanced omega-6 intake. 2. Fried foods, oxidized oils, ages, damaged bile signaling. 1. Sugar and refined carbohydrates, feed opportunists, reduce diversity. A few closing thoughts and a short disclaimer. You don't have to eat perfectly to have a healthy microbiome. The goal is to reduce repeated exposures that nudge your gut toward dysbiosis and to favor whole, fiber-rich, minimally processed foods. If you have specific health conditions, inflammatory bowel disease, severe food sensitivities, autoimmune disease, or metabolic disorders, talk with a trusted healthcare provider before making major changes. The scientific landscape is evolving. Where evidence is solid, I've tried to be clear, and where claims are contested, I've flagged them. Practical, sustained changes are the most reliable path to a healthier gut. If this guide helped you and you want a full playlist on repairing the gut, including meal examples, an easy week of grocery lists, and a science-backed approach to fermented foods, subscribe and check the playlist linked in the description. Share this video with someone who lives on packaged snacks or could use a clearer roadmap to gut-friendly habits. Remember, your gut is an ecosystem, not just a digestive tube. Small, consistent improvements in what you eat and how you prepare food give your microbial community the support it needs to protect your immune system, keep inflammation in check, and help you feel better, inside and out.